Welcome everybody. In this video, you will learn about one practical application of physics, which is present in heat chapter, especially in calorimetry. Okay, in the heat chapter, in the calorimetry, we have a concept. For major metals, heat is directly proportional to pressure. Okay, for major metals, melting point is directly proportional to pressure. Okay, which means if pressure increases, okay, melting point of the object decreases. Okay, if pressure increases, melting point of the object decreases. Before knowing about this, what is melting point? What is MP? Melting point is the temperature. Okay, melting point is the temperature at which a solid metal is converted into liquid. Okay, it's not a solid metal, it's a solid. Okay, like ice will be converted into water at 0 degrees centigrade. Okay, ice will be converted into water at 0 degrees centigrade. Water will, okay, and metals, okay, iron will convert into molten iron. Okay, solid iron will convert into molten iron at one temperature. Solid copper will convert into molten copper at one temperature. Like this, we have different temperatures, right? The temperature at which one solid metal, a solid material, will become liquid material, we call as melting point. Okay, so in physics we have melting point is inversely proportional to pressure. Okay, in physics we have melting point is inversely proportional to pressure. What does it mean? If the pressure increases, then melting point decreases. Normally, if iron, let's take iron, okay, at normal pressure, okay, if it melts at 1100 degrees centigrade, okay, assume iron melts at, I'm saying assume, I don't know the perfect melting point of iron, okay, assume iron melts at 1100 degrees centigrade, okay, assume iron melts at 1100 degrees centigrade at normal temperature, okay, at normal temperature that iron will convert into liquid, okay, the iron will convert it into molten iron, okay. If we increase the pressure, okay, in both cases we have increased some much huge pressure on the iron, okay, we have increased a huge pressure on the iron. Then what happens? If the pressure increases, okay, if the pressure increases, then it shall melt at less pressure, sorry, it shall melt at less temperature also, okay, it shall melt at less temperature also. Even if you increase more and more pressure, it can melt at 50 degrees as well, it's not necessary. It can melt at 50 degrees also, if depending upon the pressure that is acting on it. Okay, depending upon the pressure that is acting on it. Okay, so this is the concept. Okay, melting point is inversely proportional to pressure. If pressure increases, the melting point of the material or metal decreases. Okay, so where do we use it? Normally, it is used in companies. Okay, very large manufacturing companies where we have less amount of heat. Okay, where we have less amount of heat, but we need to melt the entire material. Okay, in that cases, in large factories they use it. Okay, but where is the practical usage? Okay, where is the practical usage of this one? Okay, so before knowing physics or before thinking about the practical explanations of physics, I don't know about this one. Okay, I used to say it is present in industries. Okay, especially in iron industries, copper industries. Okay, I used to say like that. But after going to two temples, okay, after going to two temples, okay, after going to these two temples, I have found out that this concept is utilized as a custom, okay, or a culture in these two temples. Okay, these two are built. These two temples are built before 500 years. Okay, its age are more than 500 years. Okay, so I have observed one thing. Okay, what is that? Okay, what is that culture? Okay, what is the culture? The culture is whenever a devotee enters into these temples, whether it is I have gone to only these two temples, which I have observed this one. Okay, whenever a devotee enters into the temples, okay, when he observes that if any small holes are present to the walls, okay, okay, we will travel in the queue, right? We will see the wall. Whenever we see a small holes are formed, okay, then damn surely they need to keep one coin in between those holes. Okay, then damn surely they need to keep the coin in between those holes. Okay, that is the custom. Okay, that is the culture. Why they have kept like this? When I was a child, I have gone and seen this. I don't know what is the reason. When I passed my class 10, still I have gone to the temple. I don't know what is the reason. I have completed my graduation, still I have gone to this temple, still I don't know. Once I started to explain the physics concepts, I got the idea. Okay, after explaining this concept, I decoded it. Why? Because, so what is the science present in it? In ancient days, okay, whatever the temple it may be, they are made of huge size of rocks. Okay, huge sized rocks. Okay, cement is not invented during that time. Okay, cement was not invented during that time. So they used molten steel. Okay, they used molten steel as cement. First they will keep one rock. After then they will pour the molten steel all over it. Then they will keep the another rock on it. Again here molten steel. Okay, again they will keep the molten steel here. Again they will keep the rock. Like this they used to construct ancient temples. Okay, molten steel used to be the cement. Okay, Okay, steel is a metal, right? So this steel is present between two. Okay, this steel is present between two rocks. Okay, and gravity is acting on them and normal force. Okay, gravity is acting in this direction, normal force is acting in this direction. So huge amount of pressure is acting in between molten steel. Okay, huge amount of pressure is acting in the middle one. Okay, in the molten steel. Okay, this pressure used to be acted for huge number of years, some hundreds of years. Okay, when this pressure continuously acts, okay, when this pressure continuously acts on this molten steel, then what will happen? Okay, the molten steel this steel used to become liquid. Okay, it starts melting. Okay, it starts melting at 50 degrees itself. Normally it will melt at so many hundreds of degrees, but it started to melt at 50-40 degrees also. Okay, not melting means not completely, only a little and little particles. As a result, the steel used to come out like this. Okay, the steel used to come out like this in microparticles. Okay, not as completely. Okay, only a microparticles, just like dust particles. The steel used to come out of it. Okay, just like dust. So what happens if this dust comes out continuously for hundreds of years? There will be some hole formed in between them. Okay, if the same process continues, then there will be some hole will be formed between them. Okay, so the ancient people who constructed this temple, okay, they know about this one. Like after hundreds of years, damn surely some holes will be formed, and if this procedure continues, then damn surely the entire temple gets collapsed. Okay, so to balance that one, to balance the whole, okay, they have given a custom that to keep one coin. Okay, they have given a custom that to keep one coin in between them. Okay, the steel coin or copper coin, whatever it may be. Okay, if we keep a coin in it, again some pressure will be acting on it, and it will undergo for the next 10 to 100 years. It will undergo some pressure. After then, it will start become melting. Okay, it will start melting. Okay, once it gets melted, what will happen? Okay, this will become as a liquid and it will enter into the deeper parts. Okay, it will enter into the deeper parts, and if there are small holes present in it, it will go and cover it. Okay, it will go and cover it. Okay, and also if pressure increases, then temperature of the object also increases. Okay, so what happens? Already the inside steel. Okay, the inside steel, whatever it may be, okay, it is present with very huge amount of temperature. It is already present with very huge amount of temperature. Okay, when these small particles, low temperature objects, this coin is present only for few number of years, right? Its temperature is less when compared to this internal steel. Okay, these molten parts, when these small molten parts, okay, small coin molten parts, okay, coin parts enter into the inside part, it will drag the entire heat. Okay, it will drag the heat from it, not the entire, but some of it. Okay, it will make the steel to cool down. Okay, it will make the hot steel to cool down. Okay, such if this procedure continues completely for hundreds and thousands of years, then the extra pressure, okay, extra pressure that is acting, we are removing it. Okay, the extra heat that is generated inside, we are removing it, okay, by using the coins. Okay, by this procedure, okay, by using this custom, this culture, okay, makes the temple to stay strong for thousands of years without any damage. Okay, without any damage. Okay, this is the reason why they they have asked us to keep the coins for the temples, okay, inside the holes. So is it necessary for now, whatever the temples that are constructing right now, is it necessary for them? Not at all. Okay, not at all necessary. Why? Because we are using cement, we are not using the molten steel to fix it. Okay, we are using the cement, right? So we don't need to use the coins. Okay, so this is the culture present in it, and this is the science behind that culture. Okay, this is the science behind that culture. If you are a physics teacher or a science teacher, please explain this to your students. If you are a student, please explain to your friends and juniors. Okay, that will make you a greater impression in front of them. Okay, that will provide a greater impression in front of them, which will be useful for you. Okay, everyone likes to be great in front of others, right? That's why. Okay, try it. Got my point? So this is the situation. I hope so you understand the science present behind this one, and you have got very clear idea about this. Okay, I'm not saying you to subscribe my channel. Okay, I'm asking you to have knowledge, study. Okay, whatever the subject that you are learning, don't learn for marks, learn it for knowledge. Use it whenever it is necessary. Okay, use it whenever it is necessary. Thank you.